Okay, let's get these last two from this block done. So x equals absolute of y, and then 2x equals minus y squared plus 2. So that's 24. Let's draw 25. X equals sine y. And then x equals cos 2y. And then y equals pi over 2. Y equals minus pi over 2. Okay, so for 24, well, it's just this region here. So I just need to get that point. It's symmetric, so it's twice the integration from 0 to that number. The quadratic minus y. No, I don't think that's right. Check again. Is that 1? Oh, I have to be careful because the 2 here, so that gets divided by 2. So that is over 2. So that would be twice 0 minus a half y squared plus 1 minus y dy. Okay. Yeah, that's if you solve the quadratic, that's at minus 1 plus root 3. Yeah. Yeah, so if you sub that in, let's check it out. Minus 1 plus root 3 squared times minus 1 plus 2 divided by 2. That's minus 1 plus root 3. Yeah. Yeah, so I just got that again by just solving this equal to y. Just looking at the positive values of y only, so I can drop the absolute symbol. So that becomes 2 times the integration, or put in the integrate now, minus y cubed over 6 plus y minus y squared over 2. And the 0 is not going to matter, so just at y equal to minus 1 plus root 3. Let's type that in. And minus answer cubed over 6 plus answer minus answer squared over 2 times 2. That is minus 8 plus 6 root 3 over 3. Okay, now on to 25. Does that look about right? It's nearly 1 unit. Yeah. It's not. What is this value here? That's a 2, isn't it? No, that's a 1. So that would be 1 unit. So it's nearly half and nearly half. So nearly 1 unit, 0.8. Yeah, okay, that seems believable. Oh, now 25. Okay. So let's start here. This looks really similar to the one we got earlier. Okay, so it's the integration from minus pi over 2 to this value here, which I'll just call for the moment alpha. The blue curve, which is the cos 2y minus sine y dy, plus the integration from alpha to pi over 2. Sine y minus cos 2y dy. So that would be a half sine 2y plus cos y minus pi over 2 and alpha plus minus cos y plus sine 2y, a half of that, plus a half sine 2y alpha pi over 2. Now let's try and get the alpha. So to get the alpha, I need sine y to equal cos 2y. That means I have sine y equals cos squared y minus sine squared y, which is 1 minus cos squared y. No, I should change it to sine squared. Because cos 2y is cos squared y minus sine squared y. And then cos squared y is 1 minus sine squared y. So that means I have 2 sine squared y plus sine y plus 1 equals 0. Oh, a quadratic doesn't have solutions. No, that's not right. I've done something wrong, clearly. Oh, minus 1. Okay. A half or minus 1. So sine y equals a half or minus 1. Well, the minus 1 answer gives me minus pi over 2. And then the second answer for that oh, actually, no, minus 1 for sine. Yeah, it only happens at minus pi over 2 or equivalently 3 pi over 2. Same thing basically. Pi over 6 is for the other answer. And then that would be 5 over 6 pi. So let's just forget about the negative answers. Which one of these three is that one? Possibly the smallest one, pi over 6. Pi over 6 would be about 0.5. That looks like pi over 6. That looks like pi over 6. Okay. Let me check it out. A half sine 2 times pi over 6 plus cos pi over 6 minus cos pi over 2 plus 1 over 2 sine pi. That's 3 root 3 over 4 minus a half sine minus pi plus cos minus pi over 2 minus cos pi over 6 plus a half sine pi over 3. Root 3. Root 3. Dun, 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 dun. No, I'm off a little bit. Root 3 over 2. I'm off by a factor ever so slightly. Let me check something here. Minus, and then check if their answer is right or wrong. Just weird that I'm off by such a factor. 25 root 3 root 3 over 2, whereas I got 4 root. Oh, I thought. Okay, a sign mistake. Is it? No. 3/4 minus 1/4. No. 3/4. 6 over 4. It's like I missed the 3 on this one. Maybe I did. Maybe I just typed it in wrong. Let's type it in again. Let's type it in. Okay. It's a half sine 2 x plus cos x. Okay. A half sine 2y cos y. Okay. So let's sub in pi over 6. Okay, and then let's sub in minus pi over 2. Okay, and it's 9 minus 10. So that one is root 3 root 3 over 4. Okay, let's check the next one. Minus cos y plus a half sine 2y. Okay, let's sub in pi over 2 and then sub in pi over 6 and then 14 minus 15. Root 3 over 4. That's looking like the same answer. That's what I'm getting. 12 plus 17. Yeah, that's what I'm getting a moment ago. Root 3. And then that's root 3. But that's not right. I must have something wrong with my integration. What is wrong with my integration here? That's definitely minus pi over 2. Pi over 6 is 0.5. That looks like that. And then from there to pi over 2. And then that red one is the sine one minus the cos one. Whereas this one is the cos one minus the sine. So what have I done wrong? What have I done wrong? Let me show you what I am talking about, why I think it's wrong. Because you can do this integration in one go if you want. If you type in absolute cos 2y minus sine y, and then integrate, whoops, and then integrate, and then integrate from minus pi over 2 to pi over 2. Oh, it's a bit confused about the absolute. I'm not sure why it is. Because it's giving me a plus minus answer. That's kind of weird. It's very weird, actually. That's kind of weird. Very strange this question is. Tree root tree. Huh. Okay, let's get rid of this here. Okay, so let's do cos minus sine minus pi over 2 to pi over 6. Okay, so that's that one we agree with. Okay, and then let's switch it around. Pi over 6 to pi over 2. Oh, that's 3 root 3 over 4, so that one is wrong. Okay, so I'm doing something wrong here. But earlier I got that here, so I must be typing something in wrong here. What have I done wrong? Minus cos y plus a half sine 2y sub in pi over 2 sub in pi over 6 subtract. So I've done something wrong with the integration, of course. Sine y becomes minus cos y. And my sign mistake. How? So that's how that becomes a tree. I guess. That's how I get. Ah, dear. Dear, oh dear, oh dear. Sign mistakes, huh? 3 over 2 root 3. It is correct. I just made a sign mistake. Must be painful to watch the video and not be able to tell me when you spot the sign mistake. I have to wait and discover it for myself. Oh man, I'm annoyed at myself.